Hi, today we are going to see about the cellular concepts and frequency reuse in wireless communication. A cellular network comprises of cells, mobile telephone switching center, public switched telephone networks, base stations, mobile users. The dotted line shows cordless connections, the solid line shows wired connections. The principle of cellular network. Underlying technology for mobile communication, personal communication systems, wireless networking, developed for mobile radio telephones. It replaces high power transmitter receiver systems. Typical support for 25 channels over 80 kilometers. It uses low power, short range and more transmitters. The cellular architecture is shown in this figure. It is subdivided into mobile station, base station subsystem, network subsystem. Base station controller and base transceiver station. In this, one base transceiver station is allocated per cell. One base station control can control multiple BTS. It allocates radio channels among BTS, manages calls handoffs between BTS and controls handset power levels. Mobile switching center connects PSTN and switches calls between base station controller. It provides mobile registration, location, authentication, contains equipment identity register. Home location register and visitor location register provides call routing and roaming. VLR, HLR, MSC functions are generally in one equipment. Equipment identity register contains a list of all valid mobiles. Authentication center stores the secret keys of all SIM cards. Each handset has a international mobile equipment identity number. Multiple low power transmitters, that is 100 watts or less, area divided into cells, each with own antenna, each with own range of frequencies, served by base stations. It consists of transmitter, receiver and control unit. Adjacent cells on different frequencies to avoid crosstalks. The shape of cell, square, with D cell has 4 neighbors at distance D and 4 at distance D. Better if all adjacent antennas equidistant, simplifies choosing and switching to new antenna. The diagonal range between two cells extends to 1.4 D. Hexagon provides equidistance antennas which overcomes the diagonal distance in the square. From all sides, the distance is same in hexagon. Radius defined as radius of circumcircle. Distance from center to vertex equals length of sides. Distance between centers of cells, radius D is R. Not always precious hexagons. Topographically limitations, local signal propagation condition, location of antennas changes the hexagon shape. Frequency reuse. It is the concept of using the same radio frequencies within a given area that are separated by considerable distance with minimal interference to establish communications. The benefits of frequency reuse is it allows communications within cell on a given frequency. It limits escaping power to adjacent cells. It allows reuse of frequencies in nearby cells. Uses same frequency for multiple conversations. 10 to 15 frequencies per cell is used in frequency reuse concepts. Allow communication within cell on given frequencies. Limit escaping powers to adjacent cells. It allows reuse of frequencies in nearby cells. N cells all using same number of frequencies. K total number of frequencies used in systems. A reuse factor of 4.7 is given in this figure. Each cell is generally 4 to 8 miles in diameter with lower limitations around 2 miles. Frequency reuse using 7 frequency allocations is shown in this figure. Frequency reuse uses cluster technology. Each cell uses totally the different set of channels with the other in the same. Minimum distance between two cells using same channel. The co-channel interference for satisfactory signal quality caused by transmissions of co-channel cells. Characterizing frequency reuse in this, minimum distance between centers of cells that use the same band of frequencies is given by d. R is the radius of a cell and small d is the distance between centers of adjacent cells, that is d equal to r into root 3. N is the number of cells in repetitive pattern in cluster. Hexagon cell pattern following values of n possibles, that is n equal to I square plus j square plus ixj, I, j is equal to 0, 1, 2, 3, etc. d by r equal to root 3 to n, d by small d equal to root n. Cells with the same number have the same set of frequencies. For hexagonal cells, the reuse distance is given by d equal to root 3 n into r, where r is the cell radius and n is the reuse pattern. Reuse factor is given by d divided by r equal to root 3 n. Assessment. What is cell? What is frequency reuse or frequency planning? What is hard and soft handoff? Thank you.